one of the main reasons why definite integrals are useful in the real world and in mathematics is because they give us the area between the curve and the x-axis, provided if f of x is greater than or equal to 0 and a continuous function. But the key thing is that the function has to be on or above the x-axis for this interval from a to b. Now, before we look at the next question, I want to emphasize that when you look at the definite integral here, the a and the b, the x, the dx, all of this represents x. So this means that x is equal to a, and we plug in, again, we replace all of our little x's with the lower bound, and this b means that x is equal to b. So when we have to write up our definite integral explanation of setting up the integral, just keep in mind that these bounds are x bounds. They're describing x's because at the end of the day, we're going to plug in x for the upper bound, lower bound of a and b. All right, so this question asks us to find the area of the shaded region. And you'll notice that this curve is above the x-axis, and so it falls under the category of that this area will be equal to the definite integral, and we have to find our bounds. Now, remember, our bounds are always x values. So the lower bound is -2, and then the upper bound is +3. Now, just giving you this as a picture, you cannot solve the problem. All you can do is you can say that the lower bound is -2, upper bound is 3. They have to give you a definition for what this curve is. And so off to the side there, you might see that it says like x squared plus 4 is equal to y. And so that function definition becomes our integrand. So we will have x squared plus 4 as the integrand dx. So once you have it set up, then you just need to integrate. And so integrating here, I would have x to the third over 3. Remember, with antiderivatives or integrals, we add. So the standalone constant does not go to 0. We add on to it, and it becomes a plus 4x. Now, because we have bounds, we're not going to add plus c. We are going to plug in the upper bound minus the lower bound. So what we will do is we will start by plugging in 3. So we will have 3 to the third over 3 plus 4 times 3. Minus, and then we'll plug in our -2 to the third over 3 plus 4 times -2. All right, so again, the 3 is replacing all of our x's here, and then the -2 will replace all of our x's in the second bracket. And then you just have to be super careful about your simplification of this. So the 3 to the third, notice that you really could cancel out one of those exponents. So you'll get 9 plus 12. Then you have minus. Now inside of this bracket, we have a -2 to the third. So that gives us a -8 over 3. And then minus 4 times the -2 will give us a -8. Now, the big mistake that can sometimes happen here is we can be a little negligent on how we distribute this negative. So just remember that this negative needs to get distributed to this as well as to the -8. So that becomes 9 plus 12, so minus and then plus the 8 over 3, and then plus 8. And then if you add all those numbers together and get your common denominator, you will get 9d5 over 3. Now, just really quickly, let's set up another example. So here what we have is we are trying to find the area of the graph 50 plus 3x squared over the interval -2 to 4. And if I just set this up only, what will happen is the integrand will be 50 plus 3x squared. And then this whole thing about over the interval -2 to 4, that is telling you the bounds of integration. So what this is saying is that we have our little parabola and we are going to integrate it from -2 on the x-axis to 4 on the x-axis. So we will plug in -2 as the lower bound and then 4 as the upper bound. And again, this question is somewhat similar to what we just did. We integrate, plug in the upper bound, plug in the lower bound, and that is going to give us -92. But it is important to see it set up that you take your function and then these bounds, this interval is our x value from -2 to 4, and then of course we have to add the dx.